Here we'll be working several compound interest examples. The amount of the investment will be $3,000 invested at quite a handsome return of 8% per year. And we're going to find the value of the investment after 8 years if the interest is compounded annually, quarterly, monthly, or continuously. So there's 4 examples built into this one example. Now, importantly, to do compound interest for anything but continuously, you'll have the following model. So compounded n times per year, you get the following model. And in this model, the A is the value of the investment. T years after depositing the principal. P is the principal. So it's the amount of the investment, the initial investment amount. N is the number of times per year as indicated in the heading here. N is the number of times per year. And T, in any situation, T will be the number of years. And R will be the interest rate as a decimal. Sometimes referred to as the APR, annual percentage rate. And if it's compounded continuously, then you have A of t is equal to P times e to the RT. The P, R, and T are the same in both models. What changes is how often the interest is compounded. The way compound interest works is you have money building on top of money, and the interest is not calculated on the initial investment. Instead, the interest is calculated on the present value as time passes. All right, so those are the models we'll be using for these 4 tasks. Annually, this means that n is equal to 1. So we'll be using A of t is equal to P, which was the initial investment of $3,000, times the quantity 1 plus the rate, and the interest rate was 0.08, 8%. The n is 1, and so we get this here is 1 times t. We don't actually have to write that 1 up there. I'm writing it for instructive purposes. So here in simplified form, this would be A of t is equal to 3,000 times 1.08 to the t. And we want to know the value after 8 years, and so we will evaluate A of 8, which is 3,000 times 1.08 to the 8, and that's approximately $5,552.79. All right, so basically, while 8% is still a handsome return, we'll find that annual and compounding annually is not ideal. All right, next is quarterly. And this corresponds to 4 times per year, every 3 months. And so it's A of t is equal to the principal, which was 3,000, times the quantity plus the interest rate, 1 plus the interest rate divided by the number of times compounded, which is 4, and raise all of that to the 4t. Simplified, that's A of t is equal to 3,000 1.02 to the 4t. Plug in 8, and we have 3,000 times 1.02 to the 32, which is approximately $5,653.62. So you can see that you get over $100 more by compounding every 3 months instead of waiting a full year to earn your interest. So that compounding quarterly would be better than compounding annually. Now if we do this monthly, this corresponds to the number of times in a year compounded being 12. And so our model would be A of t is 3,000 times the quantity 1 plus 0.08 divided by 12 to the 12t. And simplifying this, we would have A of t is equal to 3,000 times 1.006, and the 6's repeat forever, to the 12t. Evaluate this after 8 years, and you have 3,000 times 1.006 with the 6's repeating to the 96. 12 times 8 is 96. And that comes out to approximately $5,677.37. So better still. It's only about $24 better than quarterly, but it is better nonetheless. And in fact, if your initial investment was larger, you'd see even more pronounced gains. Lastly, we will compound continuously. And this means we're going to use the model sometimes referred to as PERT. We're going to have A of t is equal to the initial investment times e to the 0.08t. And we're going to evaluate that for 8 years. Or at 8 years. And so we get 3,000 e to the 0.64. And this is approximately $5,689.44. So better still, another $12 better to compound continuously. Continuously would be even faster than every second or millisecond.